Well, good morning, or as you pointed out, good afternoon, Pradeep. We're so glad that you could meet with us today. Tell our listeners a little bit about who you are and how you're getting involved in space.
Hi, good afternoon. I'm Pradeep Shinde. I'm the founder of a company startup called SpaceLoon. SpaceLoon stands for Space Balloon. The reason for it, this is the unique first of its kind balloon which will actually go to the space. That's why it is Space Balloon. Now, what is difference here is the conventional balloons, they only go up to altitude of 35 kilometers at the max generally. We take balloon to 80 kilometer, which is very high end of mesosphere. That's where the space begins, around 100 kilometers. That's why space balloon. My educational background is I have a PhD in mechanical engineering and currently building space balloon at Embry-Riddle Aeronautical University campus area. So um, how I came to space, it's a whole different, it's like that thing drove me there. My education was in mechanical and aerospace is little bit different, even though they are related. But I used to be involved in the CubeSat development programs that was funded by NASA Florida Space Grant Consortium. And actually I can say SpaceLoon is a product of that program itself. I did several CubeSat launches using weather balloons, and while doing that, we came across the problem why balloons do not go to the altitude where it's supposed to go. And that led to the foundation of one step into the another one. That's where we are in this space flow.
Wow. Excellent. So I want to, there's a lot of things to unpack here. There's the technology, your tie-ins to CubeSat, Space Grant. We actually have interviewed Dr. Mukherjee, one of our favorites. He's a wonderful friend. I know both to you and to me. In fact, he's the reason we were connected, right, through Dr. Yes. Mukherjee. Yes. But let's go back to your education. You are a relatively newly minted PhD in yes. Mechanical engineering. Could you talk a little bit about your educational experience yes. and then bring us to, we'll go to the formation of your company and the fact that you're at an incubator now in Daytona Beach. So yes. share a little bit about the education and how you ended up being a startup.
Sure. I came here to study master's in the United States the first time around 2007. When I was doing my education, it was, remember, that was also about the time where economic, the breakdown or the recession was happening, about to start at that time. And I wanted to gain experience something which is I cannot get anywhere. Let's say if I go back to my country after my master, that's what my plan. So I searched for what can I do related to space, something. I actually found there was one team doing CubeSats at Florida International University where I was doing my master. So I joined that program and it was very interested. That's the first time the CubeSat program from Florida Space Grant was launched and we participated in that. That led me further my quest, or I can say my desire to do something more. And then I found out what is the another biggest challenge when the economic depression hit and everybody was people were getting laid off and some people were trying to get stuck with some software job so they can stay alive. I was looking for, let me find out what is the biggest competition that I can at least have some fine print, and then I may will go back to my country, but I will have something that I did. So I found out some of these Shelico competition that happen across the continent of the United States, which involves like 7 countries. I'm like, okay, this looks like interesting to me. So I did that, and then I gained those experience by participating into that I can actually achieve things much better than I can even imagine. I never thought I can have footprint on this continental level. We came 5th among 20 competitors. They were from Penn State University, MIT. You take the name, they were there. So that encouraged me to further pursue my education into PhD. I'm like, I think I should do PhD. Few of my friends, very good friends, they told me to, I think you should go for PhD. Until then, I didn't thought of it. Then I went for PhD. When I was doing PhD, generally, if you look, people generally, or let's just say students generally focus on their simulation part of the PhD or experimental part of PhD. I did both. At the same time, I also did my 2 additional programs, which is the CubeSat development. It's an extracurricular, but 4 years, I developed several teams doing CubeSat activities, launching the payloads concurrently. So I try to say I did 3 or 4 PhD at the same time.
Right.
In that time frame. And then when I was doing those weather balloon launches, I wanted my CubeSat to go in the space. That was like dream of my life. Once the CubeSat go in the space, I did everything what I wanted to do. That's what I was thinking. But because of the challenges of launching anything in the space, our CubeSat never went to the space. You know, you have to wait for rocket launches and it needs to get selected. We were selected as second participants. So first 2 teams collaborate to launch it. It didn't happen. So I'm like, I need to find a way. And that's where the SpaceLoon is that medium that I will be enable the launching of the CubeSat for student CubeSat without even wait a very early, quicker, within very low budget that Florida Space Grant can fund an individual project and that can go space. That's where we are heading with the SpaceLoon.
Right. So what I heard was, it was the out of necessity, right? You had this desire, like a lot of us, to go to space. Exactly. And CubeSats represent a great way for low cost entry to space. But even then it's expensive, right?
Correct.
And you're dependent on a lot else.
Well, that's what I was thinking too, is, you know, obviously I met Kevin through the CubeSat program that he had at a school that we were both working at. And since then, it's kind of like, how do you replicate that? That's always the question we get. So the biggest issue with doing CubeSats as an educational tool has always been the cost. So it sounds like, and correct me if I'm wrong, that doing it through a balloon launch would greatly reduce the cost and make it more accessible to students even at a younger age. Is that right?
Exactly. So imagine this thing. If you see even the James Webb's launch a couple of days ago, yesterday actually it happened, right? The rocket goes vertically up and then it becomes horizontal. James Webb got horizontal somewhere around 77 kilometers around that age. So rocket generally gets horizontal between 50 and 70 kilometers. So that is the altitude it tries to go atmosphere. And the rocket needed to go until that altitude costs about 2/3 of is the entire rocket cost. So if you have an alternative that you take it to that altitude that only the rocket which will be deployed in the space, your cost dramatically decrease more than an order of magnitude. So that can enable this much more cost-effective transport to the low Earth orbit. That's where we are heading to.
So for our younger kids, what Dr. Shinde is describing is the J-turn, right? When you launch a rocket, you go vertically to get through the thickest part of the atmosphere first. That takes a lot of energy, therefore a lot of cost. And then the rocket, of course, to get into orbit, you have to make a J-turn. You have to turn and end up being sort of parallel to the surface of the Earth. And what you're saying is, if you can put your balloon up there and avoid all of the vertical ascent cost and place your rocket and CubeSat at the very edge of the atmosphere, you are disruptive because you're incredibly lower cost, right?
Yeah,
but what about the time factor? I mean, how long does it take then for the balloon to get to that point where it would be on that edge?
So correct. So the ascent rate of a balloon is generally around 5 or 6 meters per second. So it can take around, let's say, 3 hours at the top around that time.
That's still nothing. That's
right,
nothing.
right. We when we launch our high altitude balloons, and we can only hit, I do this with our students as a way to train them about the CubeSats, especially the radios. But we actually try to get no more than 5 meters per second ascent rate because we feel like our balloons will burst prematurely. And I don't think we've ever gotten a telemetry packet above about 33 or 34 kilometers, 33.
Hmm.
And that's right around 100,000 feet for our imperial folks. But yes, and you said 80 kilometers. SpaceLoon will go to 80 kilometers. Basically, that's the extreme. I mean, there's no atmosphere left up there. Would you like to share a little bit about how your SpaceLoon company is going to get something that's so disruptive up to that altitude at a reasonable cost?
Correct. So I can share what I can share here, right? So first of all, I would like to say that this one, I pursued this one by reaching out to NSF first, because these are the people, top scientists in the world. If they can verify this concept, and they can either disregard me or they can encourage me, one of these things will happen. In 2018, when I submitted proposal, that's what the reviewer said, this is exactly what we found and this is possible. The problem is you submitted to SBIR and you don't have a company. So that's where we start formation in the company. About the technology part of it, if you see the existing technologies, the way even the ballooning we do is, we see, okay, I need to go to this altitude, put this much helium and this much weight is there and it will go. If I need to go higher altitude, reduce the weight or reduce the helium, take the time. So this kind of adjustment we do, there is only so much limit that we cannot do. So there is a point where physics doesn't allow you to go beyond that. What happens is, so there is a world record from JAXA Aerospace, and in 1976, actually, United States had a 51-kilometer altitude reaching balloon. That's the maximum US had. But in 2003 and 13, JAXA had a world record of 53 kilometer, around 53.7, something around that. So what they're doing is reducing weight, is reducing the thickness of the balloon material. That is so much thin now, it is 2.7 micron. Our hair is about 70 micron thickness. So the balloon film thickness is so thin, you cannot even see that thing, right? So that physical limit itself is gone. What we are doing is an alternative technology. We understand where the environment is. That is never been considered. And we manage the changes happening with the balloon material, all the things we take into account, and we make sure it goes where it's supposed to go. We demonstrated it by proof of concept funded by Florida Space Grant Consortium. And moving forward to bring it to our, the first launch should be happening sometime this year. We're looking.
That's great. Let's share for our kids that want to start their own companies. You mentioned the importance of working with the National Science Foundation. In particular, if you can get a grant from them, SBIR, Small Business Innovation Research Grant, that is incredibly powerful to you as a startup. And kids, what you want to know is NSF is one of the best ways to get third-party validation. When you are upstream in your company's lifetime or your life cycle before you get venture capitalists. So a lot of time venture capitalists will get really excited if you have the NSF logo associated with your company.
Well, let me ask a question about that then. So I think I heard you correctly in saying that you submitted the idea to NSF, but they said, but you don't have a company yet. So so that's hence how you went about afterwards and said, okay, well then now I got to create the company in order for them to give that. That's interesting. So it sounds like you have to have a company before you actually submit to get these grants for NSF.
Yes. What happened, actually, I will broaden that, what I mentioned, and also Kevin's, your point of view also. First, Kevin's point is, venture capitalists, it is my experience recently now, they are not just getting happier if you have NSF symbol, but actually all their mindset is changing towards, if you have NSF grant, then only they are going to fund you. It's almost like that. But why they are looking in that way is they feel more confident about the technology if it is funded by NSF, because their technology risk is reduced with the NSF funding. So that's there. For your point is, you're absolutely right. You need a company before you submit the SBIR proposal. That's what I did. I formed the company, but it was just for the submission. There was no actual infrastructure. There was no actual team doing those things. So for them, it was riskier to support at that stage, even though the company was formed. But because of formation of the company, it allowed me to submit to that application. So my requirement was fulfilled, but it was not enough to get it funded.
Right.
Were you at the time of the application, were you partnered with Embry-Riddle then, or has that come since?
So what it happened is, after this happened, the NSF submission in 2018. After that submission, when I got the response that they are not funding me, two requirements they told me: that I don't have a company and I don't have proof of concept. I had a mathematical formulation, because anything what can happen, everything is math. Once your math is perfect, you have possibility to engineer it. So that's what I coded that physics into math, and then going forward for engineering it. So then I went to Florida Space Grant. Look, NSF is interested funding it, but I need a proof of concept. So can you give me the proof of concept? So they gave me some small fund to demonstrate it. So I demonstrated 3 times all correct. Now my second obstacle, how do I build the company now? They told me I don't have a company, but I already have a company. So I was not sure what exactly that means. So I asked one of the NSF review, a program manager actually, and he mentioned I should go for the NSF I-Corps program. I'm like, okay, what is that I-Corps? He's like, there's a program to build the company, this thing. Until that time, my mindset was, I'm looking for the grant to build the company, but he's telling me to do something else. I ignore it initially for a few months, and then I'm like, let me just look at it. So then I found out there is the regional I-Corps, because there is one another catch. If you want to get into NSF I-Corps program, you actually need to have NSF grant for at least within 5 years. If you don't have that grant, which in our case, I don't have that grant, so there is an alternative. You go to the regional I-Corps program where you don't need a grant. So I went to the regional I-Corps program by Professor Molly. She runs from University of Alabama in collaboration with Georgia Tech University, and earlier 2021, this year. And once I completed that thing, I went to the national cohort program. National cohort program allowed me. They saw there is a potential. They saw the history of the work happen on this, and they allowed for this thing. So we did the customer discovery. Now it needed physical space. In that time, I came in touch with great people from Embry-Riddle University, Professor Bowers. He is the one who's the founder of that MicaPlex complex, and he was interested. He invited me to look at their campus and see what things are. And then I saw there are startup space companies, there modular space, there is the sensor tech. I'm like, holy thing, all space companies are happening here. I want to be part of it. I asked him. So then that's how I joined the MicaPlex. Right. And yeah.
That's great. I want to back up just for a minute. You talked about getting funding from Florida Space Grant for your proof of concept.
Yes.
For all the kids out there or the young people that want to start their companies, what's so important about what you did there is you got non-dilutive funding. You got somebody to give you money that did not dilute your ownership of the company. And that is one of the best things about the National Science Foundation is when they give you a grant through the SBIR program or any of the other funds like I-Corps, they do not take a stake in your company. So they, anyone that will give you money but not expect to get a piece of your company as a startup, that's exactly what you want, because your venture capitalist then will say, hey, NSF took a risk on SpaceLoon. They gave them money. So they like you said, they've de-risked their investment in you. So that's really great. Right. And one last thing, the MicaPlex, yes. John Mica was instrumental in getting that. He was a former congressman from that district. And Sean and I actually took students to call on his office. We've done that over the years. And this MicaPlex that you are now a part of, this incubator, was in that sort of got started because there was a congressman there that really wanted to get that, for Daytona Beach area at Embry-Riddle.
Well, I want to fast forward a little bit to the company now. So and now as you're getting this, you have kind of a concept. tell me who your ideal customer would be at this point. So like we know a little, I know very little, but I know somewhat from working with Kevin about CubeSats and what the process is once they're
Yes.
selected, how they get launched. Who's your ideal client?
Yeah, so right now, as we are doing this customer discovery, we found our the space industry customer where they need to do their technology demonstration, their technology risk reduction. So for an example, when they deploy their technology into low Earth orbit or on other planets, they are taking huge risks. They are actually, their risk reduction is based on the conventional ground-based testings, which is, they do the vacuum chamber testings, but that is limited to only up to 100,000 feet of vacuum, about 30 kilometers of vacuum. And that's why many times they have faced the failures. For an example, in 2019, there was a MOLE mission deployed to drill hole on the Mars, $830 million mission. It could not drill the hole on the Mars. It's not about just a failure in any space mission, but the PI of that mission, she now suspects that any such a kind of mission will happen in next 2 decades. So it's also a loss of hope. It happens what these scientists try to do. So for their technology risk reduction, they are very excited. They want to see this technology so they can reduce their technology risk for these space missions. So that's one.
So it almost becomes a precursor. It's like a step before sending it up. They can test it in a much more affordable fashion, and they can get data that will then confirm that this is going to work. It's fine and ready to go. Exactly.
The atmosphere there, it is like what you have the atmosphere on the Martian surface is close to around 40 kilometer altitude, what we have on Earth, but the temperature is around 60-70 kilometer altitude. So they get their proof of concept is, so the failure is like there is always an unknown for the failure for any testings you do, right? What we are doing is reducing that unknown by more than 50%. So their success rate will even increase in the region, which don't know where it's going to fail.
So you're going to be a service provider for those Correct. That want to advance their TRLs, their technology readiness levels of hardware that might be deployed on the moon. Exactly. I'm sorry, on Mars especially, right?
Both of them. Well, you mentioned the moon. That's because in the Dubai conference, I was there as well and spoke to a lot of people. The whole industry is focused on going to Artemis mission, going to Mars in next few years. And they told me industry is going to be ready in next 3 to 5 years. And that's the time it's also SpaceLoon going to take to be ready. They are looking forward for SpaceLoon to be working with them to reduce their technology risks. So moon is one of the things.
That's great. Important. Well, I know that our Wolfpack CubeSat development team is excited about working on some projects with SpaceLoon, and we think that 2022 is going to be a very good year, hopefully for you and for us and our collaboration. So I want to thank you for being with us today.
Before we go, and before I ask you my final question, which is always about like advice, but I have to go back to your original CubeSat that didn't fly. Now that you have this technology, is it gonna fly? Is that gonna be one of the first ones that goes up?
That is the first thing, not in this launch, but I intend to do this in next 5 years. This first CubeSat will be launched from the balloon itself, from the SpaceLoon itself. That's what I want to do, so it can enable this technology in proof of concept. Yeah.
And then are you going back to your home country? Because that's what you said. As soon as you do that, right? You're not now. You're going to stay, right?
I'm going to stay, but I have a lot of plans to do there as well. They should also benefit for me to be from that origin, at least in some aspect.
You know, we want you to stay here in the U.S. and employ Americans and make lots of money so that you can pay taxes and help yes. us. We need your brain power here. And but I like the idea of working with kids. We actually are looking forward to increasing the number of kids from other countries that we can work with. And we can talk more about that offline. I want to thank you for being with us here today. I really enjoyed it, Dr. Shinde.
And I know that you'll have more time with Kevin and his students, but as we always part with, any advice you have for some kid out there who might be thinking, you know what, I want to start my own company, or a university student is like, I've got this idea, I don't even know where to begin. What's your best advice for them?
Definitely, the best advice is there is a deficiency for next generation workforce where the space industry is heading to. So it is not just limited to workforce, it is also the opportunities what that workforce can bring it in. So there is a huge scope if they focus on, they just need to see what is happening, where the industry, what they are going to do in next 3 to 5 years. They have SpaceLoon available to demonstrate their concept. They can start their own business. They can focus, oh, maybe I can do something this on the moon or Mars. Let me just do this demonstration and establish myself. That can happen within the time frame of their imagination. I think they should focus on seeing the industry where it is leading and what they want to do. They will be successful.
Great advice. Thank you so much for being with us. We're looking forward to, we'll put you back in our rotation, and then a few months or a year from now, we're going to follow up on SpaceLoon and see just what good things have happened.
Is there a website that anyone can go to if they wanted to learn more before we sign off?
Yes, spaceloon.com. It's as simple as it is.
I'll make sure to link it in the chat. Well, thanks again so much.
Thank you.
Wonderful.
Thank you for your time. It was great talking to you, both of you.
Thank you.